Now let's look at absolute value equations and inequalities. And our key terms are just looking at different scenarios for when you're dealing with absolute value. So if you have the solution of, or the absolute value of x equals, and they're telling us that p is a positive number. So we have the positive, we have the negative, and we have 0. So if the absolute value of x is p, then either p or negative p are going to be solutions. The equation absolute value of x equals 0 must mean that x equals 0. And the equation absolute value of x equals negative p has no solution because absolute value is distance, and distance can't be negative, so you can't have a negative solution, which means no solution. The solutions of x greater than, or absolute value of x less than p are those numbers that satisfy x is less than p and x is greater than negative p. And number 5 is going to be the opposite of that, which probably isn't going to make a whole lot of sense until we start looking at some numbers. So let's start looking at some of these problems, and we're going to start off with just basic absolute value. What is it? What does it look like? How does it work? So we've worked with absolute value in the past, and so we're just going to revisit that. So when I have the absolute value of negative 19z, if it was just the absolute value of negative 19, we would say, oh, well, that's 19. Well, because we don't know what z is, we're going to keep the absolute value symbol around it, because if z happens to be like negative 3 or something like that, we would have to make sure we maintain that it's positivity, or that it stays positive. So whenever I have a variable, I still want to surround it with absolute value symbols just to ensure that it is going to stay positive. The only time you don't have to do that is if it's being squared. If it was z squared, I wouldn't need that, because you know that a positive times a positive is a positive, and a negative times a negative is also a positive. So if it's a variable that's already being squared, it doesn't matter what the value is, it's still going to be positive. So you don't have to have the symbols in that scenario. And we actually see that in the next problem. So on number 10, when it says absolute value of y squared or negative z, it doesn't matter what we put in for y, whether it's positive or negative, because it's going to go positive because it's being squared. So I don't have to worry about the absolute value symbols. But because of that negative z on the bottom, I am going to have to surround that with absolute value symbols, because I don't know really what that could be. So since it could potentially be a negative, we need to make sure that it stays positive. Now these kind that have numbers involved and a fraction, you want to simplify them as much as you can. So when I see negative 8 over 4, a squared over a, I can actually simplify that before I even take the absolute value. Negative 8 over 4 is negative 2, and a squared over a is a. So I've simplified my fraction. Now I can take the absolute value of it. And so that would be my final answer, 2 times the absolute value of a. So when I do the next one, 5 over negative 15, that's really, 5 over negative 15 is 1/3 negative. And then I still have x squared over x would leave me with an x on the top. Now I'd actually take the absolute value of that. I'm going to have an x in the numerator. And since it's not being squared, I'm going to put absolute value of symbols around it to ensure that it stays positive. And the absolute value of negative 3 is positive 3. Let's do one more. 72 over negative 8, that will simplify to negative 9. And x to the 5th over x would be x to the 4th. Absolute value of negative 9 is 9. And we can actually just leave it x to the 4th. Now I don't have to surround that x to the 4th with absolute value symbols because the power is 4. Just like with squared, you're always going to get a positive number no matter what you put in there. So whenever your exponent's even, you don't have to worry about absolute value symbols. If it's odd, make sure you include them. Now find the distance between the points on a number line. Whenever it says find the distance between, you're simply going to subtract. So you could say negative 11 minus negative 96, Or you can say negative 96 minus negative 11. Now, one of these is going to give you a positive answer, and the other one is going to give you a negative answer. So how do you know which one's the correct answer? Well, if we surround both of them, or either one, with absolute value symbols, then you actually would get the same result no matter what. And distance is always positive anyway, so it's good to go ahead and put that in absolute value symbols. So it doesn't matter which way you write it, because you're going to get a positive number in the end since you're taking the absolute value of it. So 96 and a negative 11 is 85, which gives you 85. Absolute value of 85 is 85. This one, if you happen to write it this way, you would have got absolute value of negative 85, which would result in a positive 85. So because distance from, or absolute value is distance from 0 when you're asked to find the distance, then just surround your subtraction problem with absolute value symbols, and then you don't have to worry about which number comes first. Now let's look at some equations involving absolute value. So let's just start off with the first one up at the top. Since we have absolute value of x equals 4.3, x could be two different things, because the absolute value of 4.3 is 4.3, so x could be positive 4.3. But if I happen to put in a negative 4.3, I would get the same thing. So, oops, I forgot to include my negative. So absolute values are going to have two answers, because both 4.3 and negative 4.3 have a distance of 4.3 from 0. Now what happens if they start plugging in different numbers in with it, and it's not just x? For example, this one is 4x minus 5 equals 8. Well, what's inside your absolute value, which is 4x minus 5, could be equal to a positive 8. Or what's inside your absolute value symbols could be equal to negative 8, because both of them would give you a distance of 8. So we need to solve both of these mini equations. So it looks like I'm going to have to add 5 to both sides on both of my equations. So that's going to give me 4x equals 13. And over here I'm going to get 4x equals negative 3. And now I have to divide everything by 4. And you don't have to solve your equations at the same time like I'm doing. I'm just doing that so you can see that I'm having to do the same operations. It's just you've got a negative and a positive that you're dealing with. So it looks like I have 13/4, or I have negative 3/4. And that's your two answers, 13/4 or negative 3/4. So it's not always going to be the positive and negative with the same number, and they're not always going to be opposites like they were on that first one that we did. Now when we get into inequality absolute value, then we have to think more in terms of your number line, because it could get confusing. So let's just think of this on a number line, since absolute value is distance from 0. I'm going to put 0 in the middle, and I think you would agree with me that both 3 and negative 3 have a distance of 0 from, which would be 3. Now when we're talking about greater than or equal to 3, so what this means mathematically is we want our distance to be greater than or equal to 3. In other words, we're getting further and further away from 0. So, for instance, 4, 5, 6, And then also on the other side, -4, -5, -6. Those numbers are getting further and further away. Their distance is further and further away from 0, which means their absolute values is definitely greater than or equal to 3. And since it could be equal to 3, then we have to do squared off brackets. So graphically, this is the situation that we have. Now to express this mathematically, we would say for our answer, because we have two distinct parts of our number line here, I could say that on this left-hand side, the highest it can be is -3, the lowest it can be is -infinity. On the right-hand side, the lowest it can be is 3, the highest it can be is positive infinity. So since both of these represent the entire solution, we put a U in the middle for union. So we have two pieces of our answer, and we put that U in between to indicate that both of them together make up the solution set for this problem. Now, if the inequality had been absolute value of x less than 3, then that would be, on your number line, getting closer and closer to 0. Less than 3 means distance is less than 3, so definitely getting closer and closer. Because it doesn't have the equal to, I would have used a parenthesis, and I'm getting closer and closer, closer and closer. So that means all of this is included in our solution. And if I'm writing this as my answer, the lowest I can go is -3, comma, the highest I can go is +3. And this would be my solution. I don't have to use a union because they all fall in that same category. This would be, if we were to write them individually, which we can do as well, this would be x less than 3 and x greater than -3. That's the two scenarios that we see here. The one up above, if we were to write it as two separate problems instead of one together, we would have said x greater than or equal to 3 or x less than or equal to -3. So that's how they would translate if we were to take the absolute value out. So we're going to use that idea to help us with a few other problems. Now the thing to remember when you're working is you have to have your absolute value isolated, meaning we can't have this +8 on this problem, so I would need to move that 8 to the other side. Oops. Well, I didn't get my symbol. I didn't put my 3 in there. There we go. That looks better. Now that I have my absolute value isolated, now I can write it into my two separate inequalities. So either x minus 3 is going to be greater than or equal to 6, or x minus 3 is going to be less than or equal to -6. Now I solve these two inequalities individually. That's going to give me x greater than or equal to 9. Add 3 to both sides. That's going to give me x less than or equal to -3. Now, depending on how they want you to write your answer, probably will be interval notation, or you might be asked to graph. I always find it helpful to graph if they're asking me for interval notation, because interval notation always looks like your graph. So if I have -3 down here, and I have 9 down here, or up here, less than or equal to negative 3, and I would shade to the left. Greater than 9, and I would shade to the right. So then if I'm writing an interval notation, I would have negative 3 as the highest, lowest would be negative infinity. I would union that with 9, comma, positive infinity. And that would be my complete solution.